change, that's going to depend on how this table actually looks, okay? So if you kept food constant, I mean, you're not going to have 4 food groups. You're going to probably have the 2 food groups, right? If you change food, if you change substrate, you're going to have 2 substrates. If you changed food and substrate, then you're going to have the 2 foods versus the 2 substrates, okay? So this is just kind of a guide, but you're going to be basing this off of what you actually, like what principles and whatever you actually changed, what variables you changed, okay? So here, it's talking about food, but here I use substrate, right? So the way you want to set it up is you're going to set it up the same way as you have here, but you're just going to use your variables. So you've got substrate 1, substrate 2, and then you've got cover 1, 2, 3, open 1, 2, 3. Okay? Don't be thrown off by the fact that there's 3 of them and there's only 2 variables. When you've got, it doesn't matter how, if you've got substrate over here or cover over here, that does not matter. What's important is that you've got your 2 substrates, and the 1, 2, 3 is just signifying your days. Okay, so you have at least 3 days of data, and the 1, 2, 3 is just corresponding to which day it is. Okay, so on your first day for substrate 1 under cover, you have 12. For the first day for substrate 1 open, that's what you've got. Okay, so that's how you're going to set this up. So you're going to have 1, 2, 3, 1, 2, 3, but that's just signifying the days. Okay, does that make sense? Yes? No? Maybe so? Okay. So for average, this is what we've done before. Average equals average of the 3 cells. You want to do that for each of your variables. It wants us to do variance, which is, when I was showing you that standard deviation equation, the variance is just before you take the square root of that. So the variance is actually just a very complicated way of kind of adding up all those, you know, individual minus the average square, all those added up. That's your variance, okay? So, long story short, the equation for that is just VAR, and then you highlight the columns. Standard deviation is, again, what we've been doing and what we've been basing off our standard, or our error bars off of. Again, standard deviation, STDEV, more things. And now we want to include standard error, and you'll notice in your statistics packet, this says that that's probably what you're going to be focusing your error bars on, or basing your error bars on. We've just been doing standard deviation, okay? So continue to do standard deviation. Don't worry about highlighting standard error for your error bars, just keep doing standard deviation. We just want to know the standard error. So all the standard error is your standard deviation divided by the square root of n, as you see in that packet. N is just the number of days that you have data for, okay? So we've got our standard deviation divided by the square root of 3 because we've got 3 days worth of data. So we've got 3 data points. Does that make sense? So that's how it's going to be. If you're reporting 4 days of data, it'll be the square root of 4, etc., etc. Okay? Okay, so now you just do your fancy pull and drop and all that fun stuff, and then report all these values in your, you can put a table in the foraging experiment to report those values. We just want to know what those values are, and then you're going to go back to your regular data, your raw data, in order to do your ANOVA, okay? So again, you have it set up substrate 1, substrate 2, cover 1, 2, 3, open 1, 2, 3. You have your data like that. Now what you want to do is you want to go to data analysis, and you'll come up with this box. You want to click ANOVA 2-factor with replication, hit OK. And then you want to highlight your entire range, just like you would for a graph, including your titles. So you highlight this, that is your range. You'll notice when your statistics packets talk about it as well, Rows per sample, again, that's your N. That's the number of data points, like number of days that you collected data. Okay, so that's 3. And then your alpha is 0.05. Okay? Now you can tell it where to put this information. It's going to, by default, put it in a new worksheet. That's fine. Just hit OK. And now it's going to spit this craziness out into a new worksheet, okay? Again, this is a lot of delicious information of which we only care about very little. So ignore all this stuff. What we care about is the p-values down here, okay? So what this is doing is it's telling you if your samples, so your your rows, if there is a significance between the rows, and this says yes. This is the same thing. Is there a difference between the columns? Yes. But the cool thing about ANOVA is it's going to tell us if there's an interaction between the two, which is what we really want to know. So because we did a 2x2 design, we want to know what the interaction between our column and our rows are. So our rows, again, are open versus cover, and then our columns are our substrates, or our food types, whatever. Okay? And here, our interaction is not significant. Okay? So again, you just want to report those values as you're reporting everything for your lab report. So when it says it's an insignificant, or when your interaction is not significant, when your p-value for your interaction is not significant, that's just basically saying that there's not a significant correlation between the two variables. Does that make sense? So that one independent variable isn't influencing the other independent variable, which we would expect to not see, right? So we would expect that there would be, based on our hypotheses about substrate depth, about cover versus open, whatever hypotheses that you put in your proposal, we would expect to see some kind of interaction. However, no interaction is okay. So if you don't have a significant p-value, again, same thing with your lab reports, that's okay, you just need to be able to explain it, okay? So if you don't have a significant interaction, that just means that the independent variables were not interacting with each other in some way. Now, the one thing to keep in mind with ANOVAs is this is just telling you if there is an interaction. It is not telling you where the interaction is occurring, okay? So if this was significant, it's not telling us where in the data it's significant. So it's not telling us if the comparison between the low and the high the low substrate and the open was significant. It's not telling us which of those 4 combinations was significant. It's just telling us that there was a significant interaction somewhere. Okay? And that for the cases, or for this purpose, that's all we need to know. All right? So you want to report all those values, and then it wants us to create another graph. And this will be your only graph in your report. Okay? So again, what it asks us to do is report the means. So it wants us to report the averages for both of our independent variables. And it'll give you, this is the example that it gives, but this is again just based off of the one variable that you're altering, which we're not doing. We're going to have 2 bars based off of what we're changing, okay? So here we've got substrate 1 with cover and open, and then substrate 2, cover and open, okay? Again, when you're actually trying to create this graph, just copy, paste special your averages for cover substrate 1, cover substrate 2, yada, yada, yada. And then you're just going to be highlighting this for your graph. And then